Hey there, ready to go on a little adventure? Because today we're going to be detectives, math detectives. We're going to uncover a secret code that's hidden inside every number. Seriously? Sound cool? Okay, let's get started.
All right, to get things rolling, let's start with a little puzzle, just to warm up our brains. Imagine you've got 6 blocks, like Legos or something. Now, the challenge is, how many different ways can you stack them up to make perfect, neat rectangles? Let's think about it. Okay, so first, the obvious one, right? You could just line them all up in one long row. That's one row of 6. Or what if we made 2 rows? Yup, 2 rows with 3 blocks in each. We could also flip that around, couldn't we? Make it 3 rows with 2 blocks each. And finally, we could stack them all up into a tall, skinny tower. That's 6 rows with just 1 block in each. Now, pay attention to those numbers we just used. 1, 6, 2, and 3. They're going to be really important. So those numbers we just found, 1, 2, 3, and 6, they have a special name in math. We call them factors. A factor is just a number that can divide another number perfectly, with absolutely nothing left over. Think of them like perfect-fitting puzzle pieces that build a bigger number. All right, so the number 6 was pretty cooperative, wasn't it? It had a few options, but what happens if we change the number? Let's take away 1 block. So now what if you only have 5 blocks? How many ways can we arrange these into a perfect rectangle? What do you think? Well, let's see. We can do that long row again, 1 row of 5. And we can do the tall tower, 5 rows of 1. And wait a minute, is that it? Yep, that's it. You can't make it 2 rows wide because you'd have 1 left over. You can't make it 3 rows. It just doesn't work. So 5 is different. It's kind of special. And this difference is actually a huge deal in math. Some numbers, like our friend the number 5, are, well, they're a bit picky. They have this really exclusive club, and they only let 2 members in, the number 1 and the number itself. That's it. Nobody else is allowed. Okay, so these special exclusive numbers, they have a very cool name. They're kind of like the superheroes of the math universe. Why? Because they're the basic building blocks that all other numbers are made of. So you ready to meet them? They're called prime numbers. So what's a prime number? It's any number bigger than 1 that has only 2 factors, just 1 and itself. That's the rule. So 2 is prime, its only factors are 1 and 2. 3 is prime, only 1 and 3. We already saw that 5 is prime, 7 is prime, 11 is prime. They're like the unbreakable atoms of the number world. Okay, so if a number isn't prime, then what do we call it? Great question. We call it a composite number. And a composite number is just any number bigger than 1 that has more than 2 factors. Remember our first number, 6? It had factors 1, 2, 3, and 6. That's more than 2, so 6 is a composite number. It's composed of other numbers. See how that works? So let's just break it down one more time. Think of it like this. Prime numbers are the Lego bricks. They're the basic, solid, unbreakable pieces. Composite numbers are the cool things you build with the bricks, like a house or a car. And just like a Lego house, you can always break a composite number back down into its original prime bricks. But hold on a second. What about the number 1? Good question. Where does it fit in? Well, how many factors does 1 have? Just 1, itself. And what's the rule for being prime? You have to have exactly 2 factors. And for composite, more than 2. So 1 doesn't fit in either group. The number 1 is just special. It's in a category all on its own. Okay, we know what prime numbers are, but how do we find them? I mean, we could check every single number, but that would take forever. Luckily, a super smart guy in ancient Greece named Aristotles came up with an amazing trick more than 2,000 years ago. He invented something called a sieve. You know, like what you use in the kitchen to drain pasta. His sieve filters out all the composite numbers, leaving only the primes. It's so cool. So here's how we're going to do it. First, we need a grid of numbers. Let's just take the numbers from 1 up to 60. Our goal, our mission, is to use this sieve method to get rid of all the composite numbers, so only the primes are left standing. Ready? Here's how it works. Step 1, we get rid of 1. We know it's not prime, so bye-bye 1. Okay, what's the next number on our list? It's 2. We know 2 is a prime number, so we're going to keep it. But we're going to cross out every other number that 2 goes into, all its multiples. So 4, 6, 8, 10, all the even numbers, gone. Now what's the next number that isn't crossed out? It's 3. Great. We keep 3 to prime, and now we cross out all of its multiples. 6 is already gone, but 9, 12, 15, get rid of them. And we just keep doing this.
So after we do that for 5, and then for 7, just look at what's left. All the numbers that are still there, the ones that didn't get crossed out, those are the prime numbers. Isn't that amazing? It's such a simple but really smart way to find them all. All right, so we know what primes are, we know how to find them. Now we get to the really, really cool part. We're going to crack the secret code hidden inside every composite number. And this isn't just a fun math game. This idea is actually what helps keep all your information safe online. It's called prime factorization.
So what is prime factorization? It's pretty simple, really. It's just the process of taking any composite number and breaking it down and down and down until you're left with nothing but its prime number parts, its prime building blocks. This special list of primes is like the number's own secret recipe, or its fingerprint, its own unique DNA.
Let's do one together. Let's crack the code for the number 18. Okay, so we start with 18. The first question you always ask is, what's the smallest prime number that goes into 18? Well, 18 is an even number, so 2 goes into it. We know that 18 is 2 times 9. Now, is 2 a prime number? Yes, so we circle it. That part of the code is done. Now we look at the 9. Is 9 a prime number? No, it's not. We can break 9 down, right? 9 is 3 times 3. And is 3 a prime number? It sure is, so we circle both of those 3s. Now look, everything is circled. We can't break it down anymore. And just like that, we did it. We cracked the code. We found all the prime building blocks of 18. They are 2, 3, and another 3. So the secret code, the prime factorization of 18, is 2 times 3 times 3. Now, to make things look a little tidier, mathematicians have a little shortcut. When you have a number multiplied by itself, like our 2 3s here, we can use something called an exponent. We just write the number 3 and then a little 2 up in the corner. We read that as 3 squared, or 3 to the power of 2. It's just a shorter way of writing 3 times 3. So the final neatest version of the code for 18 is 2 times 3 squared. And here is the absolute coolest thing about all of this. Ready? Every single composite number in the universe has its own one-of-a-kind prime code. Just like your fingerprint is unique to you, the prime factorization of 12 is unique to 12. No other number has it. This is a super important rule in math. It's a really big deal. So, what does this all mean for you? It means you've just unlocked a new math superpower. For real, you now have the ability to look at a number and not just see the number itself, but to see the secret prime ingredients that it's made of. So, let's do a super quick recap. What do we learn? 1. Prime numbers are the Lego bricks of math, the basic building blocks. 2. Every other number, the composite ones, can be broken down into a prime code that is totally unique. And 3, the best part, you now know how to do it. You can find that secret code for any number. You guys just learned how to read a secret language, the language that all numbers are written in. And it's not just a game. This secret code stuff is the reason our messages and passwords stay safe online. It's the key to something called cryptography. So now that you've unlocked this one secret, it makes you wonder, right? What other amazing secrets is math hiding? Thanks so much for joining me.